All right. 1.2 is, it's recording me. Okay. 1.2 is measuring and constructing segments. There's really only one term in here that I think you guys won't know or might be new to you, and that's congruent segments. And you might actually know about that already anyways. There is what's called postulates. Postulates we're going to use a lot in here. They're kind of like rules, okay, but we are not able to prove them. Okay, most things in math or in geometry we're going to have to be able to actually prove using other information. A postulate, we cannot prove it. It is just mathematically accepted. It's been tried so many times that we've just accepted that it works. Okay, the first postulate we have is called the ruler postulate. I'm going to assume that you guys can use a ruler, am I right? If I give you a segment and ask you to measure it, you can measure it with a ruler, right? Okay. And you guys all know that the distance between two things is how far one is from the other, right? Okay, so we're going to skip over that. We're going to skip example 1 because you should definitely know how to do those by now. Construction, what's construction mean? Like to build, okay? Could you construct a line segment 6 inches long if I asked you to and gave you a ruler? Okay, I would hope so. If I gave you a segment that was, let's say, 5 inches long, could you measure it and then match another one and draw a second one? Okay, then we're going to skip that also. Okay, congruent segments, down to our core concept. That's the information that may be new for you. Okay. Congruent, first of all, the symbol congruent looks like this. It's like an equal sign with a similar sign on top of it. Okay, that means congruent. Okay, we will use that probably every single day from now until the last day I see you before summer. We will either use that symbol, we will use the word congruent of some sort. Congruent itself, for congruent segments, that just means they're the same length. Okay, for segments to be congruent, they are the exact same length. The actual word congruent means that some two things are the same size and shape. Okay, we'll get into where we talk about congruent triangles, congruent circles, rectangles, squares, stuff like that. A triangle cannot be congruent to a rectangle, okay, because they're different shapes. Okay, even if they have the same area or the same perimeter, they cannot be congruent because they are different shapes. Okay, so take a look here real quick. I'm not going to draw this up on the board. Example 2, though, they give us 4 coordinate points, and they say to plot them in a coordinate plane. Could you guys put points in a coordinate plane for me if I asked you to? Okay, so they did that for you over on the left side. And then they ask, determine whether segment JK and segment LM are congruent to each other. Okay, since one of them is perfectly horizontal and one of them is perfectly vertical, is it okay just to count the units by the boxes? Yes. Okay, that is just fine. Okay, so Tegan, what is the length of each of those segments? Yeah, page 13. See it there? On the bottom there, in that coordinate plane. What's the length of each segment? 5 units. Are they both 5 units? Okay, so are they congruent? Yes, because they're both segments. They are the same length. And it was JK, right? Segment JK and segment LM. They are congruent to each other. That's how I would write that. Segment JK is congruent to segment LM. Okay. Think we can handle that part? Not too bad. Now, if the segments happen to be on the coordinate plane at an angle, you might have to either measure them with a ruler, or if you remember it from last year, and we'll go over it more this year, but at some point you used what was called the distance formula. Okay, So, like I said, we'll go over that more later in the year, but I don't think they're going to give you anything that is not horizontal or vertical. Okay, so moving on. We're going quickly, so if I go too fast, let me know. The next definition they have for us is the word between. I'm going to hope that you all know what it means to be between, right? I'd like to know the Webster definition of this, because the only way I can think of to define between is using the word between. It's not necessarily in the middle, but it's in between, right? Okay. So, moving on to our postulate. This postulate is one of the most important postulates we're going to have all year. It's the segment addition postulate. I'm going to do a lot of abbreviations in here. If you want to abbreviate in your notes, that's fine. Just make sure if you were to go back in 2 weeks, you would know what that meant. Okay? So don't abbreviate it if you're not going to remember what that abbreviation means. Okay? But our segment addition postulate is used when I have 3 points. In this case, I'm going to put B in between A and C. Okay. And what this postulate tells us is that segment AB plus segment BC is equal to, well, if I add those two together, what do I get? I'm going to get AC. For that whole segment, you only actually have to use 2 letters. Okay, so if I take that small segment AB and the other small segment BC, combine them together, I'm going to get that longer segment AC, right? Okay. That might seem kind of obvious, and I'm going to show you a couple examples where you've probably used it in the past and not even known. And they're going to be pretty easy, but then I'm going to give you another example that's a little bit more difficult. Okay? So, an example, does everybody have this? An example of in a scenario where you've probably already used this. They gave you this and they said, what's the length of AC? You done problems like that before? Okay. The answer is what? 14 units. Okay? Easy, right? Do you have to probably write anything down if they give you a problem like that? Probably not. Okay, the next one's a little bit more difficult sometimes. They might give you one that looks like this. And they want to know what's the length of EF. Okay. 11, right? 11 units. What'd we do? We subtracted. Again, you might not have to show work there, okay, because you understand what's going on. Okay. If you wanted to show work, okay, could you set up the segment addition postulate just in general with these letters? What would the segment addition postulate just for this diagram be? With just letters, no numbers. So it'd be segment DE plus segment EF, good. And that would be equal to DF when I added them together. Okay, and then if you needed to, I see that DE is 15 plus EF, and I could substitute 26 in there, and I could continue to solve till I got to EF, right? You might not have to do that, and I'm okay if you don't have to, but you do need to understand how to set up that equation if you needed it with segment addition. because the next problem I'm going to give you isn't going to be quite as easy. Okay. Did everybody get that? Can I move on? Okay. It's going to be more challenging when they give you something like this. And they say this is 13x plus 9, and this over here is 4x minus 7. A little bit harder just to look at it and know what the answer is, right? Now, if you were adding, if both of these numbers were down here on the bottom, not going to let me grab it, but you get what I'm saying? If they're both down here, maybe you wouldn't have to write anything out because you're just going to add them together. But when you subtract, it actually changes a lot of things. So set up your segment addition. I know that GH plus HI would be equal to GI, which, yeah, I'm just not going to substitute yet, but you're right. Okay, GH we're trying to find, plus HI is 4x minus 7, and then that's 13x plus 9. When I finish solving this out, am I going to get a single number answer, or am I going to get another expression like we have in these two places? I'm just going to get another expression, because right now I have multiple unknowns. I have GH as one unknown, and I also have X, right? Okay, so if I'm trying to find the length of GH, I'm just going to try to get it as an expression just like these other two. Meaning, I got to take this right here and get it to the other side, right? Okay. What do I need to do to get rid of the 7? Add it. And to the 4, subtract 4x. I'm going to do those all in one step. You can sure do that if you want to. So on the left, now all I have left is segment GH equal to 13 minus 4 is, try again, 9. 9x, right? 13 minus 4. Cobwebs right before lunch, huh? 9 plus 7 is 16. And that would be your answer. Is that an acceptable answer to type into Big Ideas? Yeah, absolutely. Just because it's not a single number doesn't mean it's wrong. You're going to start getting more and more answers that look like that as we move up. Okay. Questions there? Just be careful. Make sure you can set that up if you need to. Okay. The last thing I have for you is example 4, and then you can work on your assignment. Okay, example 4 states, the cities shown on the map lie approximately in a straight line. Find the distance from Tulsa, Oklahoma to St. Louis, Missouri. Okay, I will give you guys 2 minutes to work on that. They want to know how far is it from Tulsa to St. Louis. What'd you get, Paul? I think you're really close. You must have not carried right. Check again. You're super close. I just think you subtracted one part wrong. Anybody else get something taken? 361. I just think you forgot to carry your 10 there. Okay, so 361 miles. And did you use segment addition? You did. Even if you didn't set it up, you still used the fact of segment, or the idea of segment addition, right? You still knew that those two small segments added together had to equal that larger segment. You just knew to subtract then, right? Okay, like I said, you've used it for years. You just didn't know you were using it. Okay, any questions before we work on our assignment? Okay, you got the rest of the class to work. You got plenty of work time. Half hour.